solution. So for us to answer the first question, which says calculate the current in the circuit, what you need to do is, for you to find the current in the circuit, you are going to be using the formula is current is equals to electromotive force divided by R plus more R. So we are going to be using this formula to find the current. But there is an issue here. The issue is that we have many resistors in the circuit diagram. So we need to get the total resistance of the resistors. So for us to get that, we need to first of all solve for the parallel connection. Find the total resistance in parallel. So we have 1 over RT is equals to 1 over R1 plus 1 over R2, which is equals to 1 over 4 plus 1 over 5. I hope you can see that. If I call this my R1, this my R2, then I can have this. Then I can write that 1 over RT is equals to, summation of this will give us the LCM of 4 and 5 is 20. Then 4 divided is 5. 5 times 1, 5 plus 4. That is 9 over 20. I can now have that. If I do my cross multiplication, I'm going to have that 9RT is equals to 20. Therefore, RT is equals to 20 divided by 9. So RT is equal to 2.22 ohms. Now, what we have done is that we've been able to calculate the total resistance of the resistors in parallel. If we go to the formula is E over R plus R. We can now decide to, this our R now. Part of it we have calculated to be this. But for us to get this R, our R will now be total resistance in series, because if we connect this one in parallel, in series to this, it becomes series connection. So let me call this more RT. Then our RT, or this R here, maybe this R is what I'm calling RT here, which is total resistance of the resistors, must be equals to R1 plus R small t. Take note of this. R1 is this now. Then when having resolved this one, it becomes RT. So we can say that RT is equals to 3 ohms plus 2.22 ohms, which is equals to 5.2 ohms. So we have 5.2 ohms as our total resistance of the resistors. So we can now substitute into the formula. So we have I is equals to E. What is E? E is 6 volts. Let me just write the formula again. E over R plus more R, which is, our E is 6 volts divided by R. R is what? This R is RT, which is 5.2 ohms plus our small r 0.5 ohms. So what we have that I, the current in the circuit, is 6 divided by 5.7, which is equal to, so 6 divided by 5.7, 1.05 ampere. So you can see that it's really a brain puzzle question, but once you follow it meticulously, you discover that it is not really hard. In the B part of it, you are asked to calculate the potential difference across 3 ohm resistor. So What you are going to do is use the formula V is equals to IR. Voltage drop is equals to I current in the circuit multiplied by the resistance of the resistor that you want to find the voltage drop across. So this is going to be, our R is 3 ohms. We've already gotten the current to be 1.05 ampere. So we can write that V is equals to 1.05 ampere multiplied by 3. So our V is equals to 3.15 volts. So that is the potential difference across the 3 ohm resistor. I want you to attempt question 2. In question 2, you make use of these two questions we have used for this diagram. You calculate the current in the circuit, then calculate the potential difference across, instead of 3, 5. You can see that the question has changed because the diagram is not the same again. So you calculate the potential difference across the 5 ohm resistor. So please remember, you must be among the first 5 persons to get it correct. Drop the correct answer in the comment section, share the video, and follow this page, and you'll be lucky to get an airtime. Thank you.